unaffected bypass path and the effect. But the problem is your effect is always drawing down your input. It's always connected to your input. Okay? So if you've got a really low input impedance, they sucks tone, we call it. You know? It loads it down to such a way that it has an effect on the frequency response. So single-ended bypass is not the best way to go. So one of the things they have, which is probably best called double-ended bypass, is where you've got something that switches the input and the output, right? So you switch to the wire when you bypass, you switch to the effect when you're in. And that way, it doesn't matter what the effect is. And this is commonly called true bypass. I think this is a great example of marketing. There's nothing more true about that bypass than anything else. But this has become such a term that people will ask, oh, does it have true bypass? Even when it doesn't make sense to have true bypass sometimes. But it's something that people, and the definition of true bypass typically means there's some mechanical connector that it goes down and up. And that can be, you know, a big triple pole double throw switch, a double pole double throw switch, or it can be a relay. The Line 6 DL4 actually has a setting that it can be true bypass or not true bypass. And there's a reason. It's kind of cool. It's a delay timer, right? So if you're in true bypass, what it does is it uses a relay. So a relay is just as mechanical of a break as a switch. It's just it's electrically controlled. So if you've got it on, you've got delay, and you're hitting delays, and you hit your true bypass, and it turns off, and you've got a completely delay-free signal, because your delay isn't even the circuit. But if you want to make it not true bypass, you turn that off, and then you can have delay trails. So what you do is you effectively shut off the input to the delay, but all those echoes keep coming back out. You know, so that's one of these things where, you know, if you want echo trails, you can't have a real true bypass circuit. So a lot of times what you have are what's called solid state bypass, and that's what bosses use, and a number of other companies use some kind of solid state. Visual Sound is supposed to have a very good solid state bypass. The boss is kind of the standard. And what that means is that you've got a input and buffer stage, just like that first stage of the tube amp. And then you've got FET switches that determine whether or not it goes in. So instead of having these mechanical switches, you've got FETs. And that determines whether you go through the buffered bypass or through the effect circuit. And then there's a flip-flop circuit that controls effects. And the technology of the tube screamer talks about that. So read up on that to understand solid state bypass. Okay, talk a little bit about board quality. I'd like to just hit on that officially again. You've got printed circuit boards, and within that you've got various quality, and you've got aging too. The standard circuit board component is FR4. That's like just normal circuit board stuff, where for radio stuff you get the more very fine-tuned, properly designed stuff. But even within that, you've got different levels of quality. And you can usually look at the circuit and see it. Like I mentioned, I used to work on old Commodore computers, and you could look at that, and you could see like bubbling in it, and traces kind of iffy, and that was not a great quality circuit board. There are some better quality circuit boards. You also find some that are single-sided versus double-sided. The real advantage of double-sided is not that there are traces on both design. That's a great advantage for the designer. But the important part is double-sided ones have plated through holes. So when you're soldering a double-sided board, it's got plated through hole. That plated through hole is going to stay in place better than if you're dealing with a single-sided board. Single-sided board is just a trace on the surface. Those traces are very easy to erase. So you got to be careful. Big things when working on, if you're going to work on pedals, hemostats, locking tweezers is what hemostats are. Very useful, and heatsink. So that you clip on heatsink, and that's just basically a piece of metal that draws heat into itself so it doesn't go into the circuit board. But other than circuit board, sometimes you find perf board, and again, not in production pedals, but in doing yourself, you can build your own perf board. And actually, there are websites out there which have design. You can find a website with a printed circuit board, and you can download that, print that out, and etch it yourself. You can send it to like PCB Express and have them etch it. You can do something like that. You can also get what are called strip line designs. Strip lines are basically, you get a piece of circuit board that has strips of copper with holes through it. And then what you do is you go in on the back and you cut the strips in certain parts so that, you know, these three things are tied together and these two things are tied together, but now the whole five of them aren't tied together anymore. And there are websites that specialize in this type of design. So you can just buy this kind of board, go with a razor blade, cut where you need to cut it, and build your own, you know, circuit. There are also, you can also buy printed circuit boards that have the same layout as the breadboards you're used to in class. So they'll typically have like power and ground running down the center, and then they'll have, you know, 4 holes of printed traces running out. And they're convenient, especially if you just perf board something, everything translates directly. The worst case, so I'm kind of going down. I started with printed, I talked about perf board, you can do wire wrap. The worst example is there is one company who, I won't name names, but I was given a pedal from a friend, and he said, you know, I'd like this repaired, it's not working. So I opened it up, and I'm looking at it, and I couldn't believe it. There was the printed out schematic glued to a piece of cardboard from serial lines. And all the components were poked through the cardboard and soldered on the opposite side. And some do-it-yourselfer had built a pedal based on this and sold it to my friend. And then, so I'm like, oh my God. So I looked up on the website, this do-it-yourself thing, to see the description of what he says to do. It actually was in the text document to do this. To print it out, glue it to cardboard, poke everything through, and solder. Now, I don't know how the cardboard doesn't catch fire more often. Obviously, it's a bad construction technique because it's cardboard. All your wires are poking through, and then you're folded over, so you're making connections between the wires directly. So it's kind of a point-to-point thing. Turns out there are other companies that will sell you just circuit boards. So what I did for my friend was I said, look, this thing's hopeless. I'm not going to debug it. If you really love this pedal, what we'll do is I'll buy the circuit board, and I'll build up the circuit board for you. And so I completely from scratch, I bought the circuit board. I was a little surprised by the circuit board because it was a single-sided circuit board, and it was done by hand, which I thought was really strange. Because nowadays, you can go to a company like PCB Express, and you send them the CAD file, 2 days later, you get a circuit board. You know, so I was a little surprised this guy was still doing it by hand. But I think later, once he had gotten to a computerized version. Anyway, so in that case, we just rebuilt the whole thing, got rid of the cardboard. But be aware, I'm always leery buying home-built, do-it-yourself stuff because of that. You never know what was done to build it. And that same friend, he gave me 3 pedals. One that I really couldn't find anything with. I think it was just the sockets were kind of iffy. One was one of these strip line boards. Somebody built a fuzz face circuit on it using vintage germanium transistors. But instead of mounting it, you know, with screws and standoffs, used double stick tape and we put that inside the case. And the problem was the double stick tape, one of the solders was too thick and poked through the double stick tape. So, but unfortunately the board was so small I couldn't go through and really redo it. So I just, once I found the problem, I just put more double stick tape. Because there wasn't much I could do without rebuilding that. And the third one I completely rebuilt. It's not real cost effective to fix pedals. Amps makes more sense. People are willing to pay more for amps, and amps are worth more. Pedals, it's a lot of work for not much benefit. Okay, so that's construction. So now let's get into some amplitude-based stuff. The volume pedal is going to be our first. Talk about boosting or preamp. I didn't bring in my boost. Like I said, I have a LBP2, which is the original electroharmonic circuit, and that's a single transistor, just a simple gain stage. Tremolo, I brought in a digital modeling tremolo that touches on a few different, modeled a couple different types of tremolo. I don't have a ring modulator, but we'll talk about how they work. Compressor, I'm holding my DOD 280. I don't have expand.